So it's been a while since I put up a video. I think the last one was one-step equations, addition and subtraction 1. So here we're going to build on that and continue to talk about it, okay? So for our very first few problems, right, it says quickly review the rules for integer operations. You know, we're going to look at our numbers here. Which one has the greater absolute value, which one has the greater distance from 0, and determine what our solution is going to be, right? So if I have 9 minus 14, all right, it's basically positive 9 and negative 14, which means my answer is going to be negative. So now I just do 14 minus 9. 14 minus 9 should give you 5, but it's negative. So it's negative 5. All right. Here we're starting with a negative and we're moving further to the left on that negative side of the number line. So if we started at negative 9 and we continue to move to the left another 14 times, we'll end up at negative 23. Okay, here, these are the same thing. This is just negative 9 minus 14. This is negative 9 plus negative 14. It's the same thing. If I started on negative 9 and I went to the left another 14 spaces, I'd still end up at negative 23. Here, again, we're looking at our numbers. Which one has the greater absolute value? Negative 9 plus 14. 14 represents the largest distance from 0. That tells you our answer is going to be positive. So here I just take my 14 and minus my 9, and I'll end up with positive 5. All right. For what we have here, we have 1, 2, and 3. These are essentially your thinking steps, right? So this is like your checklist, what you should be going through every time you solve for one of these problems. So isolate the variable using inverse operation. Remember, this word inverse means opposite, right? So we have to get this x by itself, which means we have to get rid of this 4 using the opposite operation. So the opposite of addition is subtraction. Subtract 4 on both sides. Subtract 4 on both sides. Again, you are starting on negative 11 and moving further to the left 4 spaces, or this is negative 11 plus negative 4, in which case you would still end up at negative 15. For our checking graph, okay, since x is equal to negative 15, I'm going to rewrite my equation, but replace my x with its value. So I should have negative 15 plus 4 should equal negative 11. Well, it's true. So negative 11 is equal to negative 11. This represents our identity property. Here, I'm not really going to find a rhyme or a reason. Let's say this is 10, 11, and 12. I'm just going to plot my dot right here on the 12, or on the negative 11 rather. Actually, what it should have been was 10, negative 10, negative 11. Sorry about that. Negative 12. My bad. And so I'm just going to plot it right there on the negative 11. I should have done that better. I apologize. Number 2. Isolate the variable using inverse operations. The opposite of negative or minus 3 is plus 3. We're going to do that to both sides of our equal sign. We now have x is equal to, well, again, 12 has a greater distance from 0. It has the greater absolute value. It's just negative, right? So 12 minus 3 is going to give us 9, but it's a negative value. Therefore, x is equal to negative 9. And then when we check and graph it, we're just going to replace the x with the value that it represents. So here we're going to say negative 9 minus 3 is equal to negative 12. That's true. Negative 12 is equal to negative 12. Here I'll do it this way. We have negative 12, negative 13, negative 14, and I'm just going to plot my dot right here to represent my negative 12. Actually, I think I'm doing that not right. Oh well, we'll figure it out. I should be plotting this, right? Yeah, that's what I should be plotting. Okay, we'll fix it moving forward. Here we're going to isolate our variable using the opposite operation. So here I have -8 or -8 minus 8. That's going to give me a -40 equals x, okay? Which is fine. You can write it like this, or you can put the variable first. Either way is fine, all right? Then I'm going to rewrite it with the value that my x represents, okay? So now we have -32 is equal to -40 plus 8. -40 plus 8 is -32. Yeah, I should be plotting this here. Okay, so that's my fault. So here I'll do, we have -39, -40, -41, and I'll just plot my dot right here on the -40. Number 4, let's keep going. We're going to isolate our variable by doing the inverse operation. We have a -5 here. That means we have to add 5, and we do it again to both sides. Here we're going to have 19 is equal to x. You can also have it as x equals 19. That's perfectly fine. And then I'll rewrite it. Here we have -5 plus 19, which is essentially 19 minus 5, which will give you... No, wait. That's not 19. That's 23. That's 22. I'm silly. My bad. That's why it didn't make any sense. 22. Yay, there you go. Plus 22. There you go. That makes more sense. That'll give you 17 is equal to 17. Sorry, guys. I make mistakes. It is what it is. Here we'll start with 22, 23, 24, and I'll plot my dot on number 22 right here. All right. Isolate my variable by performing the inverse operation. If this says plus 18, I have to subtract 18. So again, this is -10 minus 18, or -10 plus -18. It's going to give us a -28. All right. Then I'll plug it in. We say that -28 plus 18 equals -10. That's true. So -10 is equal to -10. That's our identity property. And then we'll plot our value of x, okay? We'll say this is -27, -28, -29. And we'll plot our dot right here. We'll graph it right on that -28. All right, let's keep going. Here we have -25 is equal to x minus 17. So again, we have to isolate our variable by performing the inverse operation here, plus 17, plus 17. So now we have, again, -25 and positive 17. It doesn't really matter. Well, what matters here is which number has the greatest absolute value. So it doesn't matter if it's positive or negative, which number is furthest from 0. That's going to be our -25. So that means our answer is going to be negative, okay? And then we just do 25 minus 17. So I can't take 7 from 5, I borrow. That becomes a 15. 15 minus 7 is 8. But again, it's going to be negative. Therefore, 8 is equal to, or x is equal to -8, rather. Rewrite my equation by substituting the x for the value, which is -8 minus 17. That'll take us directly to -25. -25 is equal to -25. So let's do -8, -9, -10, and I'll plot my dot right there. So it's not too bad. The goal here is to isolate your variable using the inverse operations. Question A here says, how does solving x plus 7 equals 20 differ from solving x plus 7 equals -20? Okay, well, let's find out. Again, we isolate the variable by performing the inverse operation. We have x is equal to 20 minus 7 is going to be 13. But if I do this, and I subtract 7 here and subtract 7 here, I have x is equal to negative 27. So there's a pretty big difference here, in that we added a negative, or we calculated a negative value to a positive one. So in essence, again, this is a greater absolute value, so it's 20 minus 7. Whereas here, they're both negatives, so you're really just adding them. And if I were on a number line, let's say this was negative 20, when they say, okay, minus 7 more, you're going to go 1, 2, 3, 4, 5, 6, 7. You're always, anytime it's a negative, you're moving to the left of 0 or left on the number line. All right. So you got a few more, and then we're done with this one. All right. So here we got a couple of decimals. Again, not a big deal. You just have to know how to, you just have to know how to line up your decimals and your place values, okay? Opposite is going to be addition. Add 3.7. Add 3.7. Notice how my place values are lined up. My decimals are lined up, right? Now all you do is add. 7 plus 8, 15. Carry the 1. Drop your decimal. 6 plus 3 is 9. 9 plus 1 is 10. Therefore, x equals 10.5. Now this one's interesting, because for number 8, we have to do the inverse operation, right? Which is to subtract. So we have to subtract 1/4. I'm going to give myself just a little bit of room and space here, because now there's something I have to do. In order to add or subtract fractions, I have to have a common denominator. So if I'm thinking about a number that both 3 and 4 can be multiplied into to have the same common denominator, the number I'm thinking of is 12, okay? Which means I would multiply this side, both my numerator and my denominator, by 4. That's going to give me 8/12 minus, and if I need to get this 4 to be a 12, then I have to multiply this side, both my numerator and my denominator, by 3. 3/12. Now I can actually solve it. My denominator stays the same. 8 minus 3 is 5. Therefore, x equals 5/12. All right. Let's keep on keeping on here. Inverse operation to isolate my variable. That's my variable. It says add. I'm going to subtract. Minus 8.75. That cancels itself out. Minus 8.75. Again, I am keeping my place values and my decimals lined up. 5 minus 5 is 0. I can't subtract 7 from 2, so I go next door to borrow. 12 minus 7 is 5. Drop my decimal. Can't do 4 minus 8, so I do 14 minus 8. The difference between 14 and 8 is 6. Therefore, x equals 6.50. 6.5, 6.5, whatever. All right, let's keep going. Inverse operation to isolate the variable. I'm going to subtract 7.9 from both sides. Now, this one's interesting because, again, my place values and my decimals are lined up. There's nothing here. How do I represent nothing as a number? 0. Easy. 2 minus nothing is 2. I can't take 9 from 2, so I go next door to borrow. 12 minus 9 is 3. I drop my decimal. Can't take 7 from 2, so I borrow my, now it's 12 minus 7. 12 minus 7 is 5. Therefore, x equals 5.32. All right, let's keep going. All right, here, okay, similar to 8, we had a fraction. Here we had to subtract, but for this one, we're gonna have to add, okay, which is fine. Add 1/10, cross it out. Add 1/10. Now, again, we're thinking of a common denominator, right? A number that both 2 and 10 can be multiplied into. And that answer is actually going to be 10. So this one will stay the same, which makes our job a little bit easier. Here I'm going to multiply by 5 to both my numerator and my denominator. Now I have 5 tenths plus 1 tenth, which equals 6 tenths. However, 6 tenths can be simplified, okay? Common factor. A factor is a number that is multiplied into other numbers, right? So a common factor that both 6 and 10 share is 2. 2 can go into 6 3 times. 2 can go into 10 5 times. X is equal to 3/5. That's how it goes, guys. All right, let's keep on keeping on. Number 12, okay? Again, opposite inverse operation to isolate my variable. It says subtract, so I'm going to add 20.50. That's gone. Here I'm going to add 20.50. And because I don't have a lot of space, I'm rewriting this, okay? 40 as a whole decimal would look like that, plus my 20.50. 0.506. X is equal to 60.50, or 60.50 is equal to X. All right, let's keep on keeping on. All right, what value of P makes the following equation true? AKA, we're just solving for P. Okay, that's what they want us to do, and we're doing it so that we can make this equation true. So, isolate my variable, inverse operation. If it says plus, we subtract, right? Let's get rid of that. And again, I am subtracting decimals by keeping everything lined up. 5 minus 5 is nothing. I cannot subtract 9 from 8, so I must go next door and borrow. 18 minus 9 is 9. I drop my decimal. 7 minus 7 is 0. 1 minus nothing is 1. Therefore, P is equal to 10.90. Now, here it says determine if negative 8 is the solution to your equation below. Okay. So they want to know if our answer is going to be negative 8. There's actually a pretty simple way to do that. When they say determine if negative 8 is the solution, we can solve for X, or we can plug in the number for that variable, okay? We'll solve for X, then I'll show you the other way as well. So if I'm solving for X, I'm adding 13, adding 13. This is 21 minus 13. Negative 21 is going to have the greater absolute value, so my answer will be negative. And in order to do this, I have to borrow. That becomes an 11. 11 minus 3 is 8. And it's a negative. Boom. So my answer is negative 8. The other way is I can substitute it. So instead of X, I write negative 8 minus 13 is equal to negative 21. And we know that's true. If we start on negative 8 on a number line and they want us to move further to the left 13 spaces, eventually we're going to end up at negative 21. And if negative 21 is equal to negative 21, then we know this answer is true, okay? Okay, number 15, it says, Trish says that she can solve X minus 8 equals 11 by subtracting 8 from each side. Paolo says that he should add 8 to both sides. Who's correct? Well, let's look at this real quick. It's just a matter of rewriting and solving, right? So 8, they're saying that they should add it to both sides, okay? So in order to isolate our variable, we have to do the inverse operation, okay? Trish is saying that we should subtract 8. Is subtracting 8 the opposite of subtracting? No. So Trish is wrong. Sorry, Trish. Here we would have to add, and X would be equal to 19. So I would say that Paolo is correct. All right. Now, keep on looking. 3 equations are given. Find and cross out the equation that does not have the same solution. So again, we're just solving for x. That's a positive 9. So I would subtract 9 here, subtract 9 there. X would be equal to negative 16. That's what I have so far, and that's what I'm going to just write for now. Here, isolate my variable by doing the inverse operation, minus 10, minus 10. X in this case would be equal to negative 4. So far these are different. This one's going to have to be the one we're going to figure out whether it's equal to negative 16 or equal to negative 14, or negative 4 rather. So here, isolate our variable by doing the opposite. It's plus 20, so I'm going to subtract 20. Subtract 20, greater absolute value. This is 20 minus 4, but our answer is negative. So in this case, x is going to be equal to negative 16, which means this is the one that does not have the same solution as the others. All right, so that's kind of quick, but easy. So hopefully it helps.